So in this lecture we are going to see the implementation of graph, okay, that is using an adjacency matrix. Okay, this is one way of implementing a graph. One more way is adjacency list that we are already seeing. Okay, now I am making use of this particular example only, that is which we have done in adjacency list also. Now the thing is how many number of, so we are using a matrix, right? So what would be the order of the matrix? The order of matrix should be 5 into 5. Why? Because there are 5 vertices, 0, 1, 2, 3, 4. So at the row also you have to mention a matrix, you have to mention a vertices, and at the column also you have to mention a vertices. So how many number of rows and columns are there? That depend upon number of vertices are there. Right now, so this is how you will create your matrix. Fine, it's of 5 into 5 order. The order of the matrix is 5 into 5 order. Now at the beginning, what you will do, the logic of this particular program is, at the beginning you will try to initiate, means you will initialize this entire matrix to 0. You will initialize this entire matrix to 0, right? That is what you are going to do it. So for that there is one function. You can see at the main there is one function called int graph. Okay, so initiate graph. So when you call this initiate graph, okay, so this particular function will make this initialize this entire matrix to 0, right, at the beginning. So let's see how this for loop works in the beginning. Okay, then I will move to the logic part. So first you try to understand how this for loop works. Okay, so if you are already familiar with C programming, all this 2D array, then implementing 2D array, then this code is similar to that only. Okay, so you can clearly see there is I here, right? So I controls the row, right? That means to traverse the entire row, and J controls the column, so that you can traverse the entire column, right? So let's see that. So I will put I here at the beginning, right, and J here at the beginning. Fine. Now you can clearly see that I is pointing at 0th row and J is pointing at 0th column. So there you initialize it with 0. Then after that you just increment J. Okay, don't increment I. Okay, just increment J. Then I is pointing to 0th row, J is pointing to first column, right? The 0th row and first column, you just make it 0 then. Then after that you increment J. Then at 0th row and second column you just make it 0. Like after that you increment J. Now J is at third column and I is still at 0th row, right? You make initialize with 0. Then after that increment J, right? At 0th row and 4th column you again initialize with 0. Okay, and after this is over, then you increment I, right? Now again you start your J from the beginning. Again you start your J from the beginning, right? Now again J will point here. Now I is at first row and J is at 0th column, then you initialize with 0, right? Now I is at first, then after that you will increment J. Then again I is at first row and J is at first column, again you initialize with 0. Then again you will increment J, right? Then I is at first row and J is at second column, you initialize with 0, right? Then you increment J. Then I is at first row, J is at third column, increment 0. Then initialize 0, then increment J, right? Then first and fourth column, right? Initialize with 0. And after that this is finished, then again you increment I and again start J from the beginning. Are you getting it? This is how you initialize the entire matrix entire matrix with 0, right? So hope you understand the flow, right? So I think you understood the logic. Now I will show you how this code also works. Okay, so I will try to dry run this code also. Okay, so this logic, the same logic we are going to see in this coding also, right? I will show you. Fine. Now at the beginning, I is 0, right? At the beginning, I is 0 and then I smaller than V. What is V? V is 5 here, right? So you will check the condition, is 0 smaller than 5? Yes, condition is true. Then you will move to this for loop part. Then again you will check what is j equal to 0, right? J is initialized to 0. Then j is smaller than 5, V. V is what? 5, right? Right, so you will check, is 0 smaller than 5? Yes, condition is true. Then if condition is true, then you will move to this part. What it is? It is matrix. Okay, what is this matrix? See, this is the name of this array. Okay, the name of this array is matrix. Okay, this name of this 2D array. Okay, this is a 2D array, right? The name of this 2D array is matrix. So matrix of I and j. Now what is I? I is 0 and j is 0. So at 0 0, you are going to initialize 0. That means at 0th row, this means at 0th row this and column, right? At 0th row and 0th column, you are going to initialize with 0. That is the meaning of it, right? Hope you understood, right? Now next time what will happen? The control will come here, then again it will go back to for loop, right? It will not, okay, so this is how for loop works, right? Now again control will go back to for loop and it will increment now. Then j will be increment to 1. Then again the condition will be checked. Is 1 smaller than 5? Yes, condition is true. Then again it will come back to where? It will again come back to this particular matrix. Okay, now you tell me, now still I is 0, right? And j is what? I is 0 and j is what? J is 1 now this time, right? Because, so what it doesn't mean? What does it mean? That at 0th row, see, I is here, j is, now j is here now, j is at 1th position, right? So at 0th row and jth column, jth means first column, you have to make it 0, right? This is how this for loop will work. Okay, I will dry run this entire row so that you can understand this code also properly. Okay, now after this again you will go to where you will go? Again you will go back to this for loop. Okay, and again you will increment j. So when you increment j, j will become 2. Okay, then again you will check, is 2 smaller than 5? Yes, condition is true. Then what will happen? I is still 0, right? And j will be what? J will be 2 now this time. Okay, after the condition is true, it will go to here. Now that means I is still here and j is at 2. J is at 2. So at 0th row and second column you have to initialize to 0. That is the meaning of this. Right. Now after this what will happen? Again it will go to the for loop. Again it will go back to this for loop and j will be incremented. J will be incremented to 3. Then 3, check the condition, is 3 smaller than 5? Yes, condition is true. If j is smaller than 5, then it will go back to this particular statement, right? And this statement says that matrix of I in j. What is I? I is still 0. And what is j? J is 3 now, right? J is 3 now, right? So that means j will be here. So at ith 0, I is 0 and third column you have to make it 0. So at 0th row and third column you have to initialize with 0, right? Okay, now after this, next time what will happen? Again you will go back to for loop, okay, and j will be incremented. Then j will be incremented to 4. Now again it will check, is 4 smaller than 5? Yes, condition is true. Then it will come back to this particular statement, matrix of I and j. What is matrix of I and j? So I is still 0, right, and j is what, 4 now, right, and at 0th row and 4th column means j will move to this part, right. So at 0th row and 4th column you have to initialize with 0, right. Now you can see the entire row is filled with 0 now. Now what is the next step? I should be incremented to here, right. So this should happen. Let's see how in this particular code this is going to happen, right. Okay, now what will happen again after this particular initialization of 0 is happened, then again it will go to for loop will go here and it will increment to 5, right. It will increment to 5 now, right. Then it will again check the condition, is 5 smaller than 5. Now this time the condition fails, right. Then it will not get inside this particular loop, it will not get inside this particular statement. Then what will happen? Then control will move to this for loop, right, and in this for loop what will happen? It will increment I. Now in this time I will be increment to 1. Okay, that is how I will come to this first row, right, and then it will check, is 1 smaller than 5? Now yes, condition is true. Then again it will do the same thing, again go to the jth column, okay, and again all this procedure will j will again start from 0, okay, and again j smaller than v. So again j will point to 0th column and it will entirely traverse the column and it will fill it with 0, right. So okay, we will see this also we will see, so that you can understand it properly. So this time j is equal to 0, so 0 smaller than 5, condition is true, yes, condition is true. Then again matrix, okay, so it will take matrix of I and j. What is I and what is j? I is 1 here now and j is 0 here. At 1th row, first row and 0th column you have to put 0, right. So now we are going to put 0 here, right. Now after that what will happen? Control will again move to the for loop and j will be incremented. So now j will be incremented and again j will be 1, right, and this time you again will check, is 1 smaller than 5? Yes, condition is true. Then what will happen? Okay, I will be 1 only and j will be, it will again go to this part, then I will be 1 only and j will be 1, right. So at first row and first column you will put 0, right, and after that you will again move to this for loop, right. So like this you will keep on doing it, right. Now because j is here now, right. Now j will be incremented to 2, right, and again it will check the condition, is 2 smaller than 5? Yes, condition is true. Then what will happen? Matrix of 1, 2, matrix of 1 and 2, because I will be 1 only and j will be 2, okay, so that means j will be moved to here. So at first row, second column we have to put 0, right. Then like this it will keep on doing it. Then after that again control will move to here, right. Then j will be again incremented to 3. Then again it will check the condition. What condition it will check? Is 3 smaller than 5? Yes, condition is true. Then what will happen? Okay, I will rub all this thing, okay. Then again it will check the condition. So then it will get into this particular matrix, this particular statement, then matrix of I and j. What is I here? I is still 1 and j is 5 now. Sorry, j is 3 now. J is 3 now, right? The value of j is 3. So j will move to third column, right, like this. then at first row and jth column you will put 0. Right, so like this entire code will work. Okay, now next time j will be increment to 4. Right, again you will check, is 4 smaller than 5? Yes, condition is true. Again you will move here, I will be 1 and j will be 4 now. So j will be increment to 4th column, then you will put 0 there. Then at ith row, 4th column, you will put 0 here. Right, now the next time what will happen, again you will try to check the condition. Okay, again you will try to check the condition. So next time j will be increment to 5 and you will again try to check the condition, is 5 smaller than 5? Okay, this time the condition fails. Right, then what will happen, the control will directly move to the for loop now. Then what will happen, for loop, this I will be incremented. That means this I will be incremented to 2. So this I will move to 2 here. And again what will happen, j will start his journey from the 0th index again. Okay, j will again start his journey from the 0th index again. Okay, then again it will print this entire row with 0, means initializes. Then after it is after this will be completed, okay, then what will happen, I will be incremented to 3rd row and j will again start his journey from 1st column. Then again you will initialize an entire row with 0. Then again I will be incremented after completing this row. Then again j will be start from this 1st column and again you will increment the entire row with 0. Okay, so this is how you initialize the particular matrix with 0 at the beginning, right? Okay, now the next code is add edge, right? The next statement is add edge. Right, so add edge between 0 to 1. So in adjacent matrix, how we are representing an edge. For example, here in the graph you can see from 0 to 1 there is an edge, right? So how can you end from, if 0 to 1 there is an edge, that means 1 to 0 is also there is an edge. Okay, because we are using an undirected graph. Okay, remember this, we are using an undirected graph. Okay, so both the way is possible. So how can I mention that same part here in the matrix? How can I represent it? So from 0 to 1 there is an edge. So you go to 0th row, okay, 0th row, 0 to 1 there is an edge. So I will put 1 there. So if 0 to 1 there is an edge, then from 1 to 0 is also there is an edge. Okay, so I will update like this. I will update my matrix with 1. So wherever there is an edge, I just update it with 1. 0 is already there. I will just update it with 1. Right. Similarly, you can see from 0 to 2 there is an edge, right? That means 2 to 0 is there is an edge. So I will go to 0th row, okay, and 2nd column. So from 0 to 2 there is an edge, so I will put 1 there. That means 2 to 0 is also there is an edge, so I will put 1 there, right? So you understood how I am filling this matrix. So this is how, wherever there is an edge, whenever there is edge exists, you just put 1 there, okay, and there is no edge, then definitely 0 is already there, right? So 1 represent an edge and 0 represent no edge, right? This is how the matrix will represent the adjacent matrix, right? So let's see, we try to fill this part. We will try to see the code also. So for add edge, we can see there is a code here already. Okay, let's see this, how this code will work. Okay, so at the beginning I will call this particular statement add edge 0 1. So this particular function will call this function, okay, add edge, and you will get 0 and we will get 1, right? So I will mention here somewhere u is 0 and v is 1, right? And after that you will execute this particular line of code, that is matrix of u and v. You have to initiate with 1. So what is u here? 0. And what is v here? 1. So wherever there is 0 and 1, you have to make it 1. So wherever 0 and 1, you just make it 1. Right, that's it. Right, and the next line is what? Matrix of, next line is matrix of what? V and U, right? Make it 1. So what is V here? V is 1, and what is U? 0, right? So wherever 1 and 0 is, 1 and 0 is, you just make it 1, right? So this is how you will update your particular matrix, right? I will update it properly, okay, don't worry. I just want to show you, that's why, how this code is. So I think this is very easy code compared to adjacent list, right? Fine. So you understood, right? Now again this function is over. Again you will go to next statement, that is add 0 and 2, add edge between 0 and 2. So again you will be updated, right? Now this time what is U now? Now this time U will be 0 and V will be 2, right? This time U will be 0 and 2, right? Now again this statement will be executed, matrix of U1, so 0 and 2. So wherever 0 and 2 is there, you just update it with 1, right? And here wherever V is what? 2 and U is 0, so wherever 2 and 0 is there, you just update it with 1, right? This is how you are going to update it, right? Now again next step is you will call add 1 and 2, right? So again your U become 1, your U will become 1 and V will become 2, right? And again the same thing. What is U now? U is 1 and V is 2. So U, a matrix of U and V, so this is 1 and V is 2. So wherever 1 and 2 is there, you just update with 1, and you have to do the same thing for 2 and 1, right? So for V is 2 and 1, so wherever 2 and 1 is there, you would update it with 1, right? So when you are updating it for 1 and 2, you are updating it for 2 and 1 also as well, right? Okay, similarly you call add edge 2 and 3. Okay, so 2 and 3 means this will be 2 and this will be 3. So you will get U will be 2, V will be 3, right? Then start the same thing, matrix of U and V means wherever 2 and 3 is there, that means U will be 2 and this will be 3. So wherever 2 and 3 is there, you just update it with 1, and you have to do the same thing for 3 and 2. That's why this next statement is. So V is what? 3 and U is 2. So wherever 3 and 2 is there, you just update it with 1. Okay, so I hope you understood, right? So I think you can fill the matrix after this. So I think if you understood the flow, then there is nothing. Okay, so this is one of the simplest program for graph representation compared to adjacent list, right? So I will fill this particular matrix and I will show you, right? Okay, so after filling up, this is how my matrix will look like. Okay, and you can clearly see the adjacent. Okay, if you want to recreate this particular graph, you can do it, right, using this adjacent matrix also. So you can see from 0 to 1 there is an edge, right? So you can see 0 to 1 there is an edge, and from 1 to 0 there is an edge. So 1 to 0 there is an edge. From 0 to 2 there is an edge. From 0 to 2 there is an edge, right? So you can see from 0 to 1 there is an edge, from 0 to 2 there is an edge, from 0 to 4 there is an edge. So from 0 to 1 there is an edge, 0 to 2 there is an edge, 0 to 4 there is an edge. Yes, this is right. And you can see similarly here, 1 to 0 there is an edge, 1 to 2 there is an edge. So from 1 to 2 there is an edge, 1 to 0 there is an edge. Yeah, it's working fine. For 2 to 0 there is an edge, 2 to 1 there is an edge, right? 2 to 3 there is an edge. To 2 to 0 there is an edge, 2 to 3 there is an edge, 2 to 1 there is an edge. Yes, so it's working fine. So this is matrix is working fine. It is right also. Right, so this is how you can even recreate the graph also using the adjacent matrix. Okay, so after that this particular line you have to print the graph. So printing the graph is also same, like you have to use the for loop, and the way you fill this, the way you initialize the 0, right, using the for loop, the same thing you can print it also, the same, okay, using the same logic you can print also. So let's see. Okay, so here also what you will do, again this for loop, I am talking about this particular print graph. So it will again work like this. At the beginning I will be 0 and j will be 0. Then the same way we initialize the graph, initialize the matrix, the same way it's going to print also, because we are using the same two for loops. So j will be at I 0 and j is 0, whatever the data is, you just print that, right? So you can see matrix of I and j 0 0. So whatever matrix is, you just print that. Then you increment j, okay. Then wherever I 0 and jth column, whatever the data is, you just print that, right? Then you increment j. Then at I 0th row, second column, whatever the data is, you just print it. That is 1 will be printed, right? Like this, you increment j, right? Then 0th row, third column, whatever the data is, you just print that, right? Then you increment j, 0th row, fourth column, whatever the data is, you just print it. And after completing j, right, you just increment I, right? That is what this for loop is doing, okay? Then now again you will, your I will start from here, right? Now again you will, what you will do, j will again start from 0th column, right? So at 0 0 you will print 0 again, you will print 1 again, and 0 0 is 1 now. So at 1 0, at 1 0 1 is there, right? At 1 1 now j will be incremented. So at 1 1 whatever the data is that, you will print it. Now j will be incremented. At 1 1 what is that? 1 is there, so you will print that, right? Then j will be incremented, right? At first row and third column, what is the data? 0, so you will print that. So in this way you will keep on printing the entire matrix, okay? The same matrix will be printed in your console, like 1 1 0 1 0, okay? Next time, okay, like this, 0 0 1 0 1, like this entire matrix will be printed in your output as an output, right? Okay, so after this row, return 0, after this statement, return 0. So I think this is what the adjacency matrix is all about. This is one of the easiest one. So I think, hope you understood the code and everything. Okay, fine.